So this is number 3, 2019 A/B test. Okay, yeah, I just copied the graph over here. All right, so at this point, when x equals 3, when x equals 3 over here, y is this point is y coordinate is 5, 3 and red 5. Okay, that's the point. All right, first question A, integral. Okay, negative 6 to 5 f of x dx equals 7. So what that means? From negative 6 and up to the 5. This is a part of graph, okay? Negative 6 here, okay, we don't know, right? Okay.
Yeah.
Anyway, up to here, where is it? Okay, all the way down, up to 5 over here, up to 5 altogether, okay? From here to here, from negative 6 here, okay? The area is 7, okay? Negative 6 to negative 2 up to here. This is negative 2. Okay, what is the area of this side? Okay, so altogether from here area is negative 6 to 5 integral f of x dx. That is the entire graph, right? From negative 6 to 5. That is equal to 7. But you're going to find some area between negative 6 and negative 2. But we know that the area of this one, right? From the graph. Okay, so when you take up this area from 7, you get this area, right?
Yeah.
It's okay. So now let's find the graph of this one, where from negative 2 to 5 f of x dx first, okay? We're going to find this one. So from here, that is a triangle, right? Because this is a positive area, negative area. We can see that they are both equal congruent triangle. It's going to be 0, right? This one plus this one will be 0. We don't have to calculate. It's okay. The next one. From here to here, this is half. Can you see that graph? This is a positive area. This is negative area. Still plus minus 0, right? From here, area is 0. From here also area is 0. The next one area is from here to here, right? This is a positive area. Okay. The bottom is from 1 to 2 is this is 1. Okay. So this height is 3. It's okay. At 2, the height is 3. At 1, that height is 1. That is a kind of trapezoid. Is okay? So now let's find the area of the trapezoid. Upper base, bottom base, and times height and divided by 2 is the area is 2, right? 1 plus 3 is 4, and divided by 2 is equals 2. This area is 2. Now let's find this area. This area is from, you can find it from here, right? From these squares. Okay. The area of this square is this one from here. The length is 3, the other is 3. 3 times 3 is 9 minus quarter of a circle, right? This radius equals to how much? 3. It's okay. So the area of this circle is pi r squared is 9 pi, but that is a quarter divided by 4. When you take up this area of quarter of a circle, you get this area, right? 9 minus 9 pi over 4. That's the area of this side. So this area actually equals how much? Now we got the area over here. This area equals 2 plus this one. 9 minus 9 pi over 4 equals 11 minus 9 pi over 4, right? Is it okay?
Yeah. Mhm.
All right. So to find the right area of this one, from negative 2 to 5, we take up this area from entire area 7, right? So
Yeah.
negative 6 to negative 2 f of x dx, this area is equals to what? 7 minus this is a take off, right? Take off 11 minus 9 pi over 4. Okay.
Yeah.
Recording. So 7 minus 11 is negative 4. Minus 9 pi over positive 9 pi over 4. So 9 pi, you know that, right? Is almost greater than 9. So maybe you can switch this one. Looking nice. 9 pi over 4 minus 4 is better looking, right? Yeah, this is the area from here to here. Are you okay with this? Here to here, we just find 11 minus 9 pi over 4, right? From
Yeah.
here to the last is 7. Okay, so this area plus this area equals 7. This area is 7 minus this area equals this area, okay?
Yeah.
So choice A is what? 9 pi over 4 and minus 4 is the answer, okay?
Mm.
All right. The next one, B up there. Evaluate this integral 3 and 5 and 2 times f prime x and plus 4 and dx. F prime x is inside there. This is exactly equals to what? 2 is out, 3 to the 5. F prime x dx separate. I'm going to separate.
Yeah.
And 3 to the 5, 4 dx. You can separate, right? It's okay? F of x plus g of x or minus dx is separate. F of x plus dx and plus g of x dx. Okay? That is a constant. Do you remember? K times f of x derivative is a k, already can move to the front. Okay? Yeah. You this already know that. The property of integral, right? Okay, first one is this one. This is the antiderivative f of x. Okay? This is the antiderivative f of x. We already got the f of x over here graph. Okay, this graph is what? Graph of y equals f of x. Is right? Okay.
Yeah.
Okay, so it's antiderivative of this is still f of x. So 2 times f of x, we take integral from 3 to 5. Okay, and this antiderivative of constant 4 is what? 4x. And you're gonna take integral from 3 to 5. That's it, okay?
Mm.
This one is equals to 2 to the what? I'm gonna use a parenthesis. F of 5 minus f of 3, okay? After that, this is about 4 times 5, 20, and minus 4 times 3 is about 12. That's it. So f of 5 is how much over here? F of 5, 0, right? It's okay? Can you see over here, 0? When x is 5, the value of y equals 0, right? Okay? Yeah, 0. F of 5 is 0. What is f over 3? F over 3 is given by there, over here, right? F over 3, this point, okay? This point is f over 3, but this point is given by the, okay, over here. 3 minus square root 5, okay? 3 minus square root 5. And plus 20 minus 12 is 8, okay? So, negative 3 times 2 is negative 6. Negative is positive square root 5 plus 2 square root 5 and plus 8. Is okay? Okay, now when you simplify this one, 8 minus 6 is 2. It's going to be 2 plus 2 square root 5 is the answer, okay? That's the value of integral, okay? Are you okay with this number B?
Yeah.
Okay. The next one, number C there. Function g is given by, they create new functions. Create new functions over here. G of x, this is a function of the area from, calculated from area from negative 2 some value of x, and ft. Ft is what? Same graph of f of x. We just switch right the variable to avoid the confusion, right? So ft dt. So f of x, f of t, just a different variable, it has the same graph, okay?
Yeah.
So find the absolute maximum value over there. Absolute maximum is highest point, okay, from negative 2 to 5. You're going to check it out. From here there, we count over here, highest point. Where is it? From here, getting increase over here, right? Maybe you can see that. From here, increasing. The graph is over here, increasing, right? Increasing, but slope is negative, is concave down, increasing, okay? Concave down, increasing. Are you okay with this up to here?
Yeah.
That's the original graph. Not original graph, G of X graph, okay? Under the curve, right, this area, isn't it?
Yeah.
Okay, yeah. That is the antiderivative of f of x, same area, okay? After that, x move right 0 up to the 0, that is what? Decreasing, but there is a concave down decrease. So concave down decreasing, something like this way. It's okay? It's same area, but same height now. It's okay. After that, still negative sign, okay? Negative sign is what? Concave
Down.
down, right? Concave down, still negative, still concave down, decreasing at this times. Still concave down over here. A little more.
Yeah.
No, up here. From here, concave down, but its derivative, slope is positive, right? So that is a concave up, decreasing, okay? Concave up, decreasing up to point over here. It's okay? Concave up, decreasing. After that, now increasing, right? Increasing slope of this one is positive. Okay, positive is a concave up, increasing up to here, right? Concave up, increasing. Keep going forever, right? All the way positive. Concave up, increasing. All the way increasing here. It's okay? Right after this one is still increasing. This is positive. Still increasing. There is a concave down increasing. Okay, all the way over here.
Yeah.
It's okay, right?
Yeah.
Okay, now let's find out where is the highest point over here from the graph. Okay, maybe you can see from the graph over here. This area equal to plus minus 0. This plus minus 0, right? So they're the same height. Plus minus 0, plus minus 0 here, okay? After that, always positive. So this one is what? From here, plus minus 0. This one also plus minus 0 over here, right? So still over here, they are all the way increasing. So this is the what? Highest point, we know that. Actually, we don't need to write any calculation. We just explain or draw this what the graph of what g of x. It's okay.
Yeah.
All right. So using this one, the maximum, absolute maximum is actually how much?
Maximum. Um.
What's the area from here to here? We just got already over there. We just got right there. From negative 2, 6, from negative 2 to the 5. Where is it? Oh, okay. From negative 2 to the 5 over here, right? 11 minus 9 pi over 4, right? Okay?
Okay.
Yeah.
Okay. So 9 plus 4. I mean
Yeah.
minus.
Only in this interval, right? Negative 2 and 5, okay? So
Yeah.
this, the area, right? Entire area, okay? This one plus, minus 0, plus, minus, plus 0, all the way, this is a positive. This is the right absolute maximum value there, okay? Still, 9 pi over 4 minus 11 minus 9 pi over 4, right?
And
Are you okay with this?
yeah.
This one. So absolute value at x equals 5, okay? The last one, it has what? 11 minus 9 pi over 4, right? That's the absolute value. It's okay, right?
Yeah.
Okay. Or maybe you can follow over here. Maybe if you compute, right, this highest point over here, another highest point, maybe you can find, okay, when x equals over here negative 1, okay, you can find the area of this one. This area is how much? We just got a 1 over 2, right? It's okay? 1 over
Yeah.
2, okay? But this is more height, okay? 9 pi over 4 minus 4, okay?
Yeah.
No, all together, right? All together is like 11 minus 9 pi over 4. Okay, the next one, number D. Limit x close to 1 n to the x minus 3 f prime x f of x minus arctangent x. Okay, we're going to find the limit of this one. First, we can try put this number 1 there. Okay, this is 0 over 0, or plus minus infinite, or plus minus infinite. First, we can check it out. Put this number there. 10 to the 1 minus 3 f prime 1, right? It's okay? Put this number x is a 1 there. Over x is 1 minus arctangent, I'm going to use this one, arctangent 1 there. Okay? Now check out the numerator first. Also, denominator can be 0 or no, we don't know, right? So what is the numerator first, okay? What is the value of f of 1 from the graph? F of 1 there, y is 1 there, okay? This is 1.
Yeah.
Are you okay? Arctangent 1 is what is there? Arctangent 1 pi over 4, right?
Yeah.
Set equals, you can use this one, arctangent 1. Okay, so tangent theta equals 1 there, okay? For what value of angle tangent is 1? 45 degree, right? So theta equals pi over 4. Are you okay with this? This is a pi over 4, 45, that is 1 and 1, right? Tangent is 1, over 1 is 1, okay? So that is not anymore 0. Just I put this number in there. 1 minus pi over 4, okay? but numerator 10 is there. So 3 times, what is the f prime 1? F prime 1 there, f prime 1 is, what is the slope when x equals 1? The slope of this one, okay? What's the slope of this line? 2 over 1, 2, it's okay? Any point on this line, slope is always 2, right? Constant, that is 2 there. Are you okay with this? All right. 10 minus 3 times 2 is just 6 is 4 over 1 minus 1 over 4. A little better looking, okay? You're going to make a little better looking. Maybe you can leave it this way, it's okay too, but better look at times 4 times 4, okay? That is 16 over 4 minus pi. That is better looking, right? Okay, that's the answer. Any questions on number 3?
No.
It's okay, right? Number 3, usually that are not hard. Okay, maybe you can try all of these 4 questions. It's okay? All right.
Yeah.
That's the number 3. Now move on number 4 there. We have a cylinder. It has water and with a height of h. This cylinder base is the diameter is 2 feet, the radius is 1, okay? All right.
Yeah.
This one. The rate of change height h of the water in barrel with respect to time t is what? Given by these equations. dh, I'm going to write down. dh dt, the rate of height is negative 1 over 10 square root h. That is the differential equation, right? dh dt n minus 1 over 10 and square root h. Okay. Yeah, the volume of cylinder is given by, you have to memorize this, okay? Pi r squared times h. That's the volume of cylinder, okay? Okay, now take a look at the first one. Find the rate of change of the volume of water in the barrel with respect to time. So we're going to find what? The change of the volume, rate of change. That is dB dt, right? We're going to find this one. Okay. Now we already have, right, dH dt is 1 over 10 square root h in terms of h, not any constant numbers. Okay. All right, there is some situation there. The height of the water is 4 feet when h equals 4 feet. That's right. At this moment. At this moment, dH dt is what is from here. We can say that dH dt actually at this h is 4. Put this number 4 there. Negative 1 over 10. Square root 4 is what? 2, right? That is negative 1 over 5.
Yeah.
Are you okay with this? Okay. That is negative 1 over 5. It's dH dt, okay? Now I'm going to set that one more times. dH dt at this h equals 4, the rate of change is just 1 over 5. Now this is, we say, primary equation because the relationship between volume and height. But we know that radius doesn't change. Radius is what? Constant. Okay? Don't forget this one. Radius does not change. Okay? Only height is change. Okay? So over here variable is volume is will be changed variable and h is a variable. Only 2 variable available. Okay? Now take a derivative. dB dt.
Yeah.
Pi r square h. Pi r square h prime is dH dt. That's it. Okay, r is not variable. Okay, r is not function of time. R is always r, never changed. So dH dt is given by 1 over 5. Pi r is now 1, right? Because the diameter is 2. Diameter is 2, r is 1, okay? So 1 squared still 1, and dh dt is what? Negative 1 over 5.
Yeah.
Okay? So now find out, simplify. Negative pi times 1 times negative 1 is negative pi over 5. But this one, we need by a proper unit there, okay? Always, don't forget this one, okay? What is that?
Yeah.
Where is the volume or volume is feet, okay? Red is feet, the volume is about cubic feet. It's okay?
Yeah.
Per time, where is the time? T is time in seconds, okay? So time seconds. That's it, okay? That is the dB dt. I think the number 8 is okay, right? Oh, they said why indicate unit of measure, okay? Yeah, we have to write the proper unit there, okay? Yeah, that is number 8. I think number 8 is okay, right?
Yeah.
All right. Number 2 there. When the height of water is 3 feet, now they change the value of h. When now this times h equals 3 feet. Is the rate of change height of water. Is the rate of change height of water. dh dt, right? This is the rate of change height of with respect to time is what. This is increasing or decreasing. You have to check it out. The rate is increasing, not height. Okay, a little different. Height is what when you put in the way up, the water is always what increasing, right? But DHDT sometimes very fast, sometimes very lower, right? We check it out that situations. Are you okay with this? All right. So what I'm gonna do over here? How can you find the increase, decrease? If, for example,
Yeah.
if we have a graph of y equal f of x, okay, how can you change some for the some interval for the some instant, okay, for some instant, some value of x they are increasing or decreasing. We check right y prime is dy dt, right? First derivative. Are you okay with this?
Yeah.
dy dx. We check this one, okay? If this is a positive at this point of x that's increasing, if this is a negative, all right, at this point of x, the graph is decreasing. Okay, it's just the same thing. But in this case, we're gonna check right dh dt. This increasing or decreasing, not h. You gotta be careful. So we're gonna check right the derivative of this one again. What is that? Second derivative actually, right?
Yeah.
Is okay?
Mm.
So first derivative is given by here. dh dt equals how much? Negative 1 over 10 and square root h. We take one more times, right? Take one more times. This is what? D, t, and d, right? Take this one more times. dh dt, isn't it? Well, you can use just what second prime, okay? It's okay too. But this is actually simple is what d square h over dt square, okay? A little different, right? Okay. You can use this one simply, doesn't matter. Now take derivative over to the right hand side, negative 1 over 10. This is actually equals negative 1 over 10 h 1 half, right? Okay, take a derivative. 1 half move to the front. H minus 1 is a negative 1 half. Actually, this is equals to negative 1 over 10, 1 over 20, right? 2 times 10 is 1 over 20. This is negative is square root h. Are you okay with this? That is the second derivative. Yes? Okay, now we're gonna find, right, it's the sign of this one, okay? Some value of x is a 3 there. Positive, that is increasing. Positive means this is increasing at this point, all right? h. If this is negative, when h is 3, this rate is decreasing. Okay, now put this number h equal 3 there. I forgot one thing. Oh, sorry about that. I forgot to write, what did I forgot? Did you find out? Because h is a function of a time, this is a chain rule, right? Okay? When you move over here, we take right dh dt again.
Yes, you need a restart.
That's right. I forgot this one. Oh my God. Okay, sorry about this one. So anyway, h prime. I'm going this way. H prime equals to negative 1 over 20, and this is square root h, and the dh dt. We have to multiply. Okay, we check it out. Where is dh dt? Where is dh dt over here? dh dt is about 1 over 10. Okay, we did already. Okay. Okay, I'm gonna find out dh dt first. But this time h is 3, okay, not 4, right? Okay, dh dt when h equals 3 is how much? Negative 1 over 10 times h is 3, okay? That's it. So dh dt is what? Negative 1 over 10 and square root 3, okay?
Yeah.
Now put this number in there. Now h prime, finally what is it? Negative 1 over 2, still when h equals what? 3, okay? And times, we multiply negative 1 over 10 times red 3. Are you okay with this?
Yeah.
All right, now simplify. Red 3 is out. Negative times, negative is positive. 20 times 10 is what? 200. 1 over 200 is still, this is a very small number, but still it is positive. Okay, second derivative of h is a positive means what? First derivative is now increasing. Are you okay with this? That's right?
Yeah.
Yeah, that's the reason. Second derivative is positive, first derivative is increasing, right? Same things. Okay, so the answer is what? Increasing. Okay? Not h, okay? This one. dh dt increasing, okay? Right. Or for example, if you check out what second derivative is increasing, decreasing, we check out the third derivative again, right? If third derivative is positive, second derivative is increasing. What happened there? h is what third derivative is negative, h second derivative is now decreasing. It's okay? All right. We did the B, right? Okay. Try number C. At time t is 0 seconds, the height of water is 5 feet. At beginning, that initial is height is what, 5 feet. There is some water there, okay, with the height is 5. Okay. Use separation variable to find the expression h in terms of t. Okay, so what that means? T equals what is the h when time t equals 0, that is 5. That is initial, right?
Yeah.
Using this initial, we're gonna find what the solution of these differential equations. dh dt equals to negative 1 over 10 square root h. Okay, yeah, this differential equation, this dE is separable. Always high score differential equation always can be used by this separable, okay? H is H or other one is the other side. So times dt there, when you have a times dt. But this is okay, no H, but this is H. Move to the left, okay? So 1 over square root h and dh equals to negative 1 over 10 dt. Okay, you can put it right inside, okay, or outside, that is constant, it doesn't matter, okay? Now this is separate. Now this is easy one, right? To take an antiderivative of each side.
Yeah.
Okay, maybe you can use this with h equals negative 1 over 2 dh. That is better. How can you find the antiderivative of this one? Plus 1 there, okay? So h is plus 1 is what? Positive 1 half. And divided by plus 1. 1 half, that is 2, isn't it? Okay? Over here, 1 half, 1 over 1 half is 2, right? Okay, that is 2h half, okay? That is the antiderivative. The next one over here, x over here, negative 1 over 10, that is t, isn't it?
Yeah.
Are you okay with this? This is 1 there, right? And plus c, that is the initial. I'm going to the initial, g1. Maybe this one finally equal to c, we don't know, right? Still, I'm just let this as c1. Maybe sometimes this constant change with another constant. That's why, okay? Okay, you can divide by 2. Or you can check it out, right? The initial value at this time, c1, okay? It doesn't matter. Nothing different. Okay, you can put this number when t is 0, y is 5. So 2y is 5 is square root 5, right? T equals 0, this is C1, okay? Okay, C1, it doesn't matter, okay? C1. So over here, C1 equals what? Square root 2 red 5. So this one is exactly equal this way. 2 red square root h equals negative 1 over 10t and plus 2 square root 5.
Yeah.
It's okay? All right, now we're going to express the h in terms of t. Okay, we are not done. This is square root h. First step is divided by 2. Divided by 2 is what? Square root h equals divided by 2 means times 1 over 2, right? Negative 1 over 20t and divided by 2 or times 1 over 2 square root 5. Are you okay with this? But we are not done. This is what? Square root h, not h. H is always positive, right? So make a square of both sides. H equals how much? Negative 1 over 20t and plus square root of 5 and square, right?
Yeah.
Yeah, that's the simplest I think. I think that's the final. No more simplified form, okay? That's the solution of this differential equation, okay? How to think number 4? Number 4 is not that much hard, okay? You can do that, this one, I think, A, B, C all together, okay? Yeah, that is not hard, is it?
Yeah.
Okay, after class you review, okay? Repeat it, okay? Okay.
Okay.
Oh, we did number 4. Yeah, area already given by some figure over here, okay? Every test. Do you remember, right? Yeah.
Yeah.
R is the region enclosed by the graph. G of x is, okay? It doesn't matter. This is anyway, we can handle this one, okay? Because the cosine antiderivative or derivative, we can handle it. This is a polynomial, no problem at all, okay? All right. So this is the graph over here. Up to 2. From here down. Okay. Which one is the top and the bottom? You can put this number x equals 0 there, okay? You can easily find because the initial value, this is 1, this is 1, 2, 3, 4, right? Put this number, this is better. Put this number 0 there. H of 0 is how much? 6 minus 2, 0 minus 1 squared. It's okay? 4, isn't it? Yeah, top is what? H of x. The bottom is g of x. This is the top. This is the bottom graph. All right. By definition, we're going to find the variable r, okay? Top and minus difference of any point.
Mm.
Okay, this dx, we take height over here, take integral from here to here. That forms what? Area, right? Or difference. Okay. So, 0 to 2. Top minus bottom is what? Distance, okay, between these two graphs. Top is h of x, 6 minus 2x minus 1 squared, minus g of x is a negative 2 plus 3 cosine pi over 2x, and dx. That's the area of this shaded region. But this will be okay, right? We can take right integral, okay? Definitely. Okay. First, we can separate, okay? Expand this one. It doesn't matter. Okay, I'm going to expand this one. That's better. 6 minus 2. Inside this one is x squared minus 2x plus 1. Are you okay with this?
Yeah.
Okay. So, 6 minus 2 times x squared, 2 times negative 2 is 4x, and minus 2, this is the minus plus 2 again, and the minus again, right? Minus
Yeah.
plus is a minus again, cosine pi over 2x, and dx, okay? Okay, maybe you can simplify this one from 0 to 2. Okay, number first. 6 minus 2, this is out, right? 6 out. So only 6, okay? Second one is x is next. You have only 4x. The next x squared minus 2x squared. And minus 3 cosine pi over 2x and dx. Now usually you can find the antiderivative. Antiderivative of 6 is 6x. Antiderivative of 4x is what? Divided by 2 is 2x squared.
Yeah.
Antiderivative this one is what? Plus 1 is 3, so 2 over 3 x cubed. Antiderivative of cosine is what? Sine x, okay? So 3 sine pi over 2x, but you need divided by what? 2 over pi. Are you okay with this?
Mm. Yeah.
Okay? Because that when you take a derivative, it's gonna be pi over 2 we multiply, okay? So we're gonna buy pi over 2 divide again. So it's a reciprocal, I just split, okay, flip the number, okay? 2 over pi.
Mm.
Okay, this right? Okay, I'm gonna one more time simplify. 6x, 2x squared, minus 2, 3, x cubed. 3 times 2 is what? 6 over pi, and sine pi over 2x, okay? Take integral from 0 to 2. Put this number 2 in there, okay? 6 times 2 is 12. 2 times 2 squared is 4 is 8. 2 cubed is what? 8. So 2 times 8 is 16 over 3. Okay, sorry, I just got cup, okay? 16 over 3, okay? 2 cubed is 8. And minus 6 over pi. Sine pi over 2 times 2 is how much? Sine pi, right?
Mm.
Pi over 2 times sine pi is 0, okay? And put this number all 0 there. First one is 0 because they have all x terms, they are all 0. This is also a sine 0 equals 0. They are all together 0.
Yeah.
Now this is 0, this is 0. This is 20, right? 20 is, okay, I'm with that. 20 over 16 over 3. 20 is 60 over 3. and minus 16 over 3, okay?
Mm-hmm.
16 minus 60 minus 16 is 44 and over 3, okay?
Yeah.
That's that. You don't have to write in high school, okay? Now after 9, you don't have to change a mixed number, okay?
Yeah.
That's the area. A little more work, all right?
Mm.
Yeah, because many terms are there, right? You take right many antiderivatives. Just give 1 minute, okay? Just give 1 minute. Okay, sorry. All right, the next one is region R is based of solid. This is not kind of land. We're gonna construct some things on this land. Okay, already they gave this one. You remember, right?
Yeah.
Okay, the construction, the solid type is what is it? Cross section is perpendicular to the x-axis. Okay, I'm gonna
Mm-hmm.
write down. This way. We're gonna build this way. Okay. This is the bottom base. Okay, and they already got. We don't know, right? That is triangle, square types. We don't know. Anyway, they got the area function of area. Anyway, this is some area. Okay, maybe something like this figure. Okay, yeah. Yeah, this area and some value of x over here. This area is called what? 1 over x plus 3. Okay?
Mm-hmm.
So we don't have to find what the area, right? The area is given some value of x. This is very simple now. Okay, we take integral from this area from 0 to 2 again, right? Okay, 0 to 2, 1 over x plus 3 and dx. That's the volume of this solid, right? These constructions. Are you okay with this? This is very simple, right?
Yeah.
So what is the antiderivative of 1 over x plus 3? So 1 over 2, 1 over x plus 3. It's simple, okay? That's why we're going to go directly. Antiderivative of this with the ln absolute x plus 3, isn't it?
Mm-hmm.
Are you okay with this? But inside the number x is changeable from 0 to 2. They are positive, actually. We don't need the absolute value, okay? But it doesn't matter. When you take integral, ln absolute value of 3 plus 3 is 6. 6 is positive, we don't need the absolute value, okay? And ln 0 minus 3 is 3. 3 is positive, just the ln 3, okay? That's this. Or you can use this way, ln, we can combine this one, 6 over 3, okay, using division, okay? This is it. Or ln 2 is okay too. This is better. Oh, no. This is not 3. This is 2. Oh my God. This is 2, okay? So we cannot combine, right? This is rat 5. Okay? Oh yeah, you can combine this 5 over 3 is okay too, okay? All right, the next number is C. Right, at this time you don't have to evaluate, just using expression, okay, integral expression that gives us the volume of solid generated when R is rotate about horizontal line, y equals 6. Okay, I'm gonna this is 1, 2, 3, 4, 5, 6, up to 6 of it. The graph looks like this way. 6 bit. Okay, this is x-axis, a rotation axis. Okay. Okay, this is the area we're gonna rotate this one. Okay, when you rotate this one around over here, okay, maybe a little up here, looks like this one. The graph is going down, and looks like over here there's an empty space over here, right? Looks like this way. Okay, this is a circle over here. I'm sorry, my drawing is not good. And we have two empty space over here, right? But this area, the bottom is yet the same thing, okay?
Yeah.
Okay, it doesn't matter anyway. We have to find, okay, this is from here to here, that is a large circle, isn't it? Right? Like this is from here, you're gonna make up to here, this one, right? Turn around, all together, okay? Right, turn around. That is better. So this will look like this way. Okay, that is volume. Are you okay with this?
Yeah.
This is the radius. What is the radius of the 6 minus the bottom graph? It's okay? 6 minus the bottom graph. From here, 6 minus the bottom graph. It's okay?
Yeah.
Bottom graph is what? G of x. Okay, so you can take this is 6 minus G of x. Okay?
Yeah.
But we don't have to take lobby. We don't have to evaluate. You can use G of x instead of the real equation. Okay. You know what I mean? Because we don't have to evaluate. You can use just the G of x. It's okay too. They will accept any times. Okay. This is the length of this one. But this is turned out that's the radius from here, some value. Okay. This is what? 6 minus G of x, the real. Okay, the other side is mirror, okay? So pi r squared, this is a pi times r squared, isn't it?
Yeah.
That's the volume, right? And take integral from 0 to 2 there, okay? Right.
Yeah.
But after that, you take this is out. This side volume is empty. Are you okay with this? Okay, how can you find this side? This side is what? Looks like this way. Bottom is this is top graph, isn't it?
Yeah.
You take this area, right? This is the radius of circle, right? This is radius. Is okay?
Yeah.
So 6 minus top over here, okay? So minus inside of the parentheses. Still inside, empty space is 6 minus h of x n squared, okay? This is also pi, maybe better do this one. This is a pi r outside circle, inside the circle empty, right? dx. But pi is a constant, move to the front. That's why pi is out, okay? 6 minus g over x n squared and 6 minus h of x squared dx. That's enough, okay? You don't have to replace with g of x minus 2 plus 3 cos and something like that. H of x 6 minus 2. It doesn't matter, okay? because we don't have to evaluate. You can leave this way. Still, you get like full credit. Or you can replace with this okay too, if you want it. 6 minus g of x is actually from here, negative 2. You don't have to simplify, okay? Negative 2 plus 3 cosine pi over 2x. After that, square, and minus 6 minus h of x is what? 6 minus 2, x minus 1, and square, okay? And another square, and finally dx, okay? It's the same thing, okay? But this is okay too. Okay, that is the solid, right, after rotations, okay? Let me see what time is. Okay. We cannot do this one, number 6, okay? Because I have another class, right, in 7 minutes, okay?
Gotcha.
So we cannot finish this one in 7 minutes, I think. So we can continue this one next time, number 6, okay?
Okay,
I'm
sounds
gonna
good.
write down. Just give me a minute. I'm gonna write down number 6. Not finished. Okay, you can continue this, okay?
Yeah.
Okay, after I post right on YouTube, I'm gonna send out the link to you, okay?
Okay.
Okay, yeah, good job today. Okay, review one more time, okay? All right, so I'll see you. We have class tomorrow?
I believe so.
Okay, I'll
Okay.
show tomorrow, okay?
Okay.
Okay, bye. You
Thank you,
have a
Dr.
good
Chung.
night,
Okay.
okay, bye.
Bye.